Hello, everyone. This is Pam Castricone with InfoTrust. Thank you for joining our webinar today. Really excited to have you online to talk about using Google Cloud for forecasting. Super pumped to see everybody logged in and online. So I think we can go ahead and get started. So let's kick things off. So first, just a brief note about me. I am a lead consultant and data scientist with InfoTrust, and we work with some of the largest brands in the world. I'm also an adjunct at the University of Cincinnati, teaching a course on digital analytics. Professionally, I am very interested in the statistics, predictive analytics, and modeling space. But then personally, much more into like hanging out, reading books, getting breakfast, those sorts of things. So it's a pleasure to have everybody online today. So our plan for today's session is that we're first going to talk high level about forecasting. We're going to provide an overview of the platforms and skills that were used. We have a specific project that we're going to show that, we'll kind of talk through the steps and how that all came together. We'll talk about the data, the tools that were used, and then at the end, we'll bring it all together and I'll walk you through the case study for the project. Okay, so beginning with just this high-level question of what is forecasting? What we mean when we're talking about forecasting is a way of making predictions of the future based on historical data. And it works by understanding and quantifying the trends that exist in the data. There are several different use cases for forecasting, such as helping companies improve their planning, detecting anomalies in the data, learning from past events. For today's purposes, we'll be talking about the project. This is actually a screenshot here on the right that was more designed for this improving planning type of objective. So this is a screenshot of the tool that we built, and we'll talk about it quite a bit more later on in the deck. But basically what we built for our client was a revenue forecasting tool that gives them visibility into, how are they going to end the day revenue-wise. So to do this, we are collecting data in real time and feeding that into our model so that our clients, no longer have this guesswork of, okay, it's a really important promotional day. I have a sales target I need to meet. Am I on track, based, when I come to work at 9 in the morning, or am I off track and now I have the time in my day that I can do something about it? So we'll talk more about the project itself and its particular use cases toward the end, but in the meantime, we'll talk about all the pieces that came together to build this out. So how does this actually work? Forecasting can be done in multiple different ways. There are some simple ways that people forecast, like maybe using functions in Excel. There are also more complex approaches. We are going to talk today about two different time series methods, which are statistically based. So mathematically, the way they work is that they quantify the relationships in the data. So they can actually understand the relationships between sequential data points. And when you understand those relationships, we can use them to predict what will happen in the future. So we'll be talking about the statistical methods. They're from a branch of statistics called time series. And what that means is that we're using data that's collected over time. So that's kind of one of the important factors in choosing what type of algorithm to use. So these methods are appropriate when you have data over time, whether that's by hour, by day, by week, by month, but that we have a metric that's like revenue per hour or revenue per day or something like that. One other thing I want to note here is with the methods that, or at least one of the methods we'll be talking about today, it is possible to include other data in your model, so other like external regressors. For simplicity's sake, we're not going to talk about that today, but I do just kind of want to highlight that, yes, you can use other data points, but for today's purposes, we'll just talk about a simpler use case or a simpler forecasting model. And then finally, I do like to touch on what forecasting is not. Forecasting is not magic. We're utilizing mathematical algorithms. It's a way of separating the signal from the noise. And also, I just like to call out that similar to other analyses, forecasting is subject to what you may have heard called the garbage in, garbage out principle. Being that, if you have poor data quality, it doesn't matter which algorithm or approach you take, your results are not going to be that good if you have bad data going in. So can't stress enough the importance of using high quality data to feed into any sort of modeling approach that you ultimately choose. Okay, so next we're going to talk about the platforms that we used and some of the skill sets that were required from our team for this to all come together. Okay, so first I want to talk about Google Analytics. For this project, we used Google Analytics as the data source. But just to be super clear, the time series forecasting models that we're talking about today could be used with, pretty much any data source you have. So certainly not limited to GA, but for today's example, we'll use GA data. And kind of in that same vein, we're going to talk about forecasting revenue, but you can forecast other key metrics so long as they're collected over time, like we talked about. So our particular use case today is forecasting intraday revenue so that our clients have visibility into, where am I going to end the day revenue-wise so that I can know that much earlier and if I'm on track to meet my sales goals. We also utilized two different products within Google Cloud, which is a suite of cloud computing services from Google. So we used App Engine, which basically runs our processes and model in production. And then we also used BigQuery for extracting the data that goes into the model, as well as storing the output and the predictions from the model, after it runs. We'll talk more about kind of how these pieces come together a little bit later, but just kind of wanted to set the stage so that these are the two main platforms that are coming together in this project. Okay, and then on the skill sets that existed on our team that made this project possible. So from an analyst perspective, it required an understanding of Google Analytics and then either SQL or working with the Google Analytics APIs to pull the data down. So that person was involved in, making the decisions of what data do we want to use and providing that to the team that actually built the model. From a data science perspective or a statistics perspective, we leveraged experience with statistical modeling, and that can be done, well, on our team, we used either Python or R. And we'll talk a little bit more about the models later. So we did leverage those skills as well for fitting and validating the model. And then from a data engineering perspective, we leveraged experience with scripting in Python, deploying those scripts into Google App Engine, and then also working with BigQuery in terms of pulling that data down and then writing data to BigQuery. So those are the major kind of skill sets that came together to make it happen. Okay, So now that we've kind of set the stage, let's talk more about the data. There are two ways that we can get data from Google Analytics for this project. For GA360 users, people who are on the paid enterprise version of Google Analytics, both of the options that we'll talk about today are open to you. For GA standard users, people on the free version, the second approach is available to you. So this type of project can be done regardless of which version of Google Analytics you're on. Just the way that you are going to get data in real time will be a little bit different. Okay, so for our listeners who are on Google Analytics 360, the enterprise version, there is a native integration between Google Analytics 360 and BigQuery. And if you don't already have this set up, I highly encourage you to set it up. It's really easy. So what that does for you is that when you have it set up, you can now store your complete unsampled hit level data set that is being collected by analytics into a BigQuery table that you now can access. So, I mean, basically this just opens the door for far more sophisticated, specific type of analysis that you can do. You know, GA is a robust tool. It has a lot of out-of-the-box functionality, but it can't, you know, answer every question that is relevant to your business. So being able to write your own queries or go deeper in the data to start building models, you know, like the forecasting model we're talking about today, or, you know, other types of machine learning algorithms, having this integration set up kind of opens the door for those types of opportunities and potential. So definitely encourage you to try it. You do get a credit of $500 each month, so there's a kind of a low risk way to get started with BigQuery if you're not already. Okay, so one of the things that was crucial to this project is that we needed to get the data in real time. So to do that, with the integration between Google Analytics and BigQuery, we needed to upgrade that so that we could get the data more quickly. And so they do have an option for that, and it's called their streaming export. And so what that means is that the data arrives in BigQuery within about 15 minutes of when it was generated. This is much faster than what you would get in terms of data from the UI. Even for GA360 users, it can take up to 4 hours for the user interface to get refreshed data. So being able to get it in about 15 minutes is, you know, an enormous improvement over the old approach. So we definitely leverage that capability so that we can be using the most up-to-date data possible to feed into our model. That being said, one other thing to call out, you know, in this case, we are forecasting by hour. If you were forecasting at the day level, for example, real time wouldn't be as crucial there. And so wouldn't be as necessary to upgrade to the streaming export. But, you know, for our particular use case here with hourly real-time forecasting, this was the route we went. But I guess to be super clear, not required for all forecasting projects. Okay, and so the other thing I wanted to call out is for non-GA360 users, people who are on the free version, there is a way to get real-time data from GA that you could use for this type of forecasting project. GA has a real-time reporting API that exposes some data collected by GA within, actually that API contains data within like 30 minutes of when it was collected. So it's far more limited in the dimensions and metrics that you can access, but it can be used for this type of project. And then, like I was saying with the BigQuery streaming export, if you aren't forecasting on an hourly basis and have more of a daily or weekly view, then you could certainly use the regular Google Analytics reporting API, and that would allow you to extract, the full list of dimensions and metrics that are available in Google Analytics. Okay, so before we showcase the tool itself, I do want to kind of outline for you guys the different tools that came together to make this possible. Okay, so let's talk statistics. So like I had mentioned, there are several different ways that people do forecasting. I want to highlight 2 time series approaches with you today. I picked these specifically because I think that these are good ones to get started with. I would say, these aren't the simplest methods that exist. They're also not the most complex methods that exist either. So I do think that it's a good starting point, especially if you've never taken on a project like this before. So the first one I'll cover is called Holt-Winters. And you can note here, I've called out the R and Python packages that contain the functionality to fit and run these models. So definitely would encourage you to check these out. There's certainly documentation on how to use them and how they work. So certainly would encourage you to learn more. But I will provide a little bit of an overview of what's going on with them. So Holt-Winters is an exponential smoothing technique. The math is a little bit complex, but it's a very simple to use algorithm to get started with. Essentially, it's like a moving average. So if you're familiar with a moving average, it's like they have like a window function. So they zoom in and look at a subset of the data, and then they calculate an average from that. And then they shift a little bit further back in time. They zoom in and then they take another average of that subset of data. So you basically kind of create another series by taking these averages of smaller subsets, and then your moving average is like a weighted sum of those different observations. So with exponential smoothing, it weights the more recent observations more heavily, and then data that's further in the past gets less weight. So at a high level, that's basically what it's doing. And then it uses that to predict, what will happen in the future. The other model that I want to highlight is called the SERIMA, or the full long name of it is the Seasonal Autoregressive Integrated Moving Average Model. It's a mouthful, but it's a really cool technique, and this one's my preference of the 2, and this is what we've used for the forecast project we'll walk through today. The way that this one works, it's different from Holt-Winters. This is a regression-based approach, not a smoothing approach. So it's actually it's fitting a regression model based on the previous observations of the metric that we want to predict. So what that means is if I want to predict revenue at 1 p.m., then I'll use revenue at noon as the predictor, and potentially revenue at 11 a.m. and 10 a.m. as well. So it's a regression-based method. It also does have a moving average component that models the error. So it's like a combination of a few different approaches in there, kind of all wrapped up into this seasonal ARIMA model. One thing to call out with both of these techniques is that they model 3 different aspects of the series. So they model the trend, or excuse me, the value, the trend, and the seasonality. So what that means is you can think of the value as like modeling the mean of the data. So basically if we're going to just fit a horizontal line here, it finds the right place for the horizontal line. That would be modeling the value. The trend you can think of as the slope. So we have our horizontal line, but we slant it upward so that now it's increasing, appropriately to match our data. And then finally, we're also modeling the seasonality. And so that's this cyclic behavior that you see going on here. So by combining all of those three, we get a really good approximation and understanding of what's happening in our data. So to summarize the statistics, I know this is a super high level overview. In my experience, Holt Winters is an easier model to get started with. I personally prefer the ARIMA models. I think they're a little bit more robust, but they do, there's a little bit more to take into consideration with building one in terms of validating assumptions and like your parameter selection. But I think both are attainable and a good place to get started with forecasting on your own. One thing I'll call out, I think that there are some questions that are coming in. Since we do have such a large audience today, I will take questions at the end just to make sure that we get through the full topic for today, and then I'll review and answer as many of the questions as we can. So thank you. Please feel free to submit questions as we're going through, and we'll address them toward the end. Okay, so now that we've talked about the modeling piece, we'll talk about how all of this actually comes together in Google Cloud. So we're using App Engine as the server on which to run and deploy our model. So the first step is that we collect the data in real time. So in the case of using the integration with BigQuery, we're pulling data from the BigQuery table that's becoming available within every 15 minutes. Pulling that down, we're then doing some processing on that to ensure that we don't have any duplicates, and then also to format it into the form that we need to fit it, to pass it into our model. So we have a step to get the data, get it ready for the model. From there, we pass the data into our model, the new data in real time. That generates predictions for us, which we then save down to a separate BigQuery table. And then that's basically it. From there, it's just a matter of visualizing the results of the model and making them available to people within the organization. So we've done this a couple different ways. The screenshots I have shared today are from Google Sheets. We've also used Google Data Studio. It's really just a matter of preference in terms of the client, how they prefer to see it. So either of those tools can connect to BigQuery and display the data. So there is some flexibility there, but for today, we'll show Google Sheets. Okay, so at this point, I will share kind of the larger view of the case study that we have around this project that we delivered. So to kind of sum up or summarize what the problem or pain point was that we were solving for. So it can be a real pain point, especially for our large e-commerce clients, that GA doesn't have any predictive capabilities around e-commerce or revenue. I mean, frankly, very little predictive capabilities at all. So that was a real pain point for them to not have any visibility into, how are we tracking revenue-wise on our important promotional days. So the use case there being like, if they're not on track to meet their sales goal, they can know a lot sooner and then can act on that and recover. So that was one of the major pain points. The other one is that we've heard feedback from clients that Google Analytics reporting in the user interface can sometimes be slow. For GA360 users, it can take up to 4 hours to have your data updated. And for standard GA users on the free version, it can take up to 24 hours to have your data refreshed. So having such a lag in the data becoming available, especially on those days like Black Friday and Cyber Monday, is just a real pain point to wait that long for information from GA. So our solution for that is that we built out our tool that collects the data and can report on it in real time, as well as forecasting revenue through the end of the day. So basically those are the two of the main components here, but the other one I want to highlight is alerting. So we haven't really touched on this yet, but when we're in the situation where we have what has actually happened, the actual revenue that's collected, and then we also have our predictions of what we believe will happen based on the historical data, we can do some analysis there that, if those two aren't matching up, we can detect that there was something happened, there was some sort of anomaly, and then use that for alerting purposes. So that's certainly another use case of this type of work, is just learning sooner, especially if something is not if you're not on track or something's coming in really low, and finding out that sooner so you can correct it. So just to kind of reiterate on what the business questions that we were able to answer. So the big one, knowing sooner if you're on track to meet your sales target. If you're not, knowing that it's time to launch that contingency plan, whether that's another email or a push notification, something to get the promotion back on track. And then another use case that our clients shared with us that we actually didn't even think of at the time was that they also use it, if they're having a really great sale day and they're overshooting their goals, that can alert them, even sooner if they think they might have any inventory concerns of filling a high volume. So knowing sooner if they maybe need to contact some of their distribution partners was also a win for them from using this tool. So to walk through how we see this actually all working in the real world. So imagine this scenario. It's Cyber Monday. You show up at work. It's about 9 o'clock, and it's an important day. So it's important to know, are we on track? How much revenue we generated so far, and are we on track? So in our hypothetical example here, we've got about $34,000 in, projected to end a little over 300,000. Problem is, the sales target for today is actually $500,000. So coming in and seeing this in the morning is, concern and potentially something is broken or, something's not right. So learning this, at 9 a.m. in the morning allows the analyst time to do some investigation and propose a solution to recover the day. So, perhaps there was an issue with the promotion codes that was able to be fixed in the late morning. And then you can see by checking in throughout the day how performance was recovering. So perhaps around noon, things are starting to scale back up. Starting to see now about $100,000 in revenue. End of day projection has jumped up to over 430,000. Everything kind of stabilizing throughout the day, and basically showing that by stepping in and intervening sooner, you can avoid kind of a disaster situation in terms of something was broken on a really important promotion day, and kind of mitigate any negative effects from that. So one other thing I want to share here. So we've actually built these forecasts out for many different brands, and then we actually built them at the channel level as well. So forecasting the revenue that was coming in from their different paid channels, whether that's email, paid search, social, or affiliates. So we built this out, and on like the Black Friday, Cyber Mondays of the year, our clients set up a war room where they have their teams camped out when they're monitoring in real time what's coming in, where are we projected to end out the day, and so that they can make those, nimble, agile decisions in real time to adjust their strategy based on what they're seeing. So that's what this screenshot is here. These are our clients. They've got our different dashboards set up across all these different monitors, so they can monitor what's happening across all their different brands, and utilizing our forecasts and helping to make those decisions. So I did want to just share a little insight into how our clients are using this in the real world, as well as this quote from Ryan Davis at Licenza about how just being able to get this dashboard to them provided new revenue visibility that was critical for them in their holiday weekend campaigns. All right, so thank you very much. We have a lot of time left for questions, and I see that there are already some that are coming in. So I am going to review some of the questions, and we will answer as many as we can. Okay, so our first question is how to include holiday effects in either Holt-Winters or the SREMA method. So this is a great question. I get this one a lot. So it depends. One of the things that I like a lot about both of these methods is that they are actually, I would consider them a more elegant solution in that these are not like machine learning algorithms that you throw everything in the kitchen sink at it, and it kind of runs and churns the data. These are a much more targeted approach. So we are feeding in data in real time, and so the model can detect based on how the revenue has been coming in, whether or not we're in an elevated period. So there's no like switch that needs to be flipped to tell the model like, hey, it's Cyber Monday, scale your predictions up for this. It detects that on its own and scales up automatically. So one of the things that we considered in our model fitting process is, we considered multiple different models and picked the one that had the best performance. We actually optimized for holiday and promotional periods because those are the days that matter the most. So kind of all of that is to say the model takes care of the effect of holidays on its own. It doesn't require any manual input to do that, from the user. So it stands on its own. It's a more elegant solution. Okay, I see a question here from Ryan around why anybody would need this in real time, and then I also see a follow-up about ignoring that previous question since I think I addressed it already. So if you do want to talk more about this, Ryan, feel free to submit another question, but I'll just kind of go based on what your second submission was. Okay, so let me take a look at this next question that came through. Okay, so we have another question around, we've been talking about intraday forecasting and kind of this really tight timeline and frequency, and maybe not all organizations want to or can pivot on such a short notice. Maybe that's a little too chaotic. So definitely understand that as a concern. What I would say there and reiterate is these methods can be used at different frequencies. So in this case, we're talking hourly, but you can certainly forecast at other time intervals. So whether that's daily, weekly, monthly, even if you have enough data. So the analogy that I like to make is that like the toolbox is the same, the techniques are the same. It's just the data that you feed in is aggregated differently. So certainly would say, yeah, if you think daily makes more sense for your organization, can certainly do that as well. And we have seen value in doing it at that level. So yeah, that's definitely an option. Okay, I'm going to take a look at the next question. Okay, so this one we did address a little bit in the slides, but I will reiterate. So the question is, can you forecast broken down by acquisition source or marketing channel? So yes, you can. So we actually have done that for many different brands. We've done forecasts at the channel level so that they can see, how their paid media is doing, email, paid advertising, etc. So certainly can do that as well. So definitely different applications here. You could also do it by geography, by country. So lots of different possibilities with the tools we've talked through and techniques we've talked through today. Okay, cool. We have another question. This one just came in. So the question is, how does the upgrade to streaming export work? Is it a separate module that needs to be bought? How is this built? Great question. So upgrading to the streaming export is actually very, very similar to just integrating GA and BigQuery. So if you've been through that process, basically there's just a different toggle. So when you set up the integration, it asks you, do you want the standard export or do you want the streaming export? So just a toggle, and you would select that when you're configuring the integration. In terms of like billing and accessing that, the way it works is that when you use BigQuery, you are charged for the data processing and then the storage of your data. As I had mentioned in the slides, your Google Analytics 360 account manager or representative contact would have a code that they can share with you that gives you a $500 monthly credit. So in our experience, that credit more than covers the cost that you would accrue from processing the data and storing it in BigQuery. Upgrading to the streaming export does have slightly higher processing costs, but in our experience, you have to be doing a lot of other stuff in BigQuery to become even close to hitting that $500 limit. So just upgrading to the streaming export is not going to put you over that $500. The only time we ever see anybody get close is when they're processing a lot of data on their own and doing a lot of other analysis separate from something like this. Okay, so another question just came in. How long did it take to develop this for the client, and were they on GA360 or the free version? Excellent. So the couple ways to answer this question. So we have built this out for multiple clients. So the first time, I think it took us, we built somewhere between 35 and 40 models, and it took us about 3 months, and not working full time, mind you, balancing other projects as well. So that was the first time through, and that particular client, Actually, this is, I'm kind of glad you asked this question. So when we built it out originally, the streaming export for BigQuery was not available. It hadn't been released yet. So it was built out as if they were on the free version using the real-time API. Since we deployed that was in 2017, we have upgraded them to using the streaming export from BigQuery, since they are GA360 customers. So we've done it both ways, basically, to answer your question. And like I said, our initial release with 35 to 40 models, I think took us about 3 months. Okay, I see a question in here. How much does it cost? That's a great question. So one other thing I would say is that definitely depends. I know that's not a great answer, but that could also be referring to different things. So there's costs associated with like using Google App Engine and the Google services, as well as obviously maybe the team and the resources get it set up. So unfortunately, I don't think I can answer that question kind of in a vacuum. I'm actually going to launch a poll for everyone right now. So one thing, with everything we've talked through today, if you would like more information or have more targeted questions, feel free to let us know, and we can certainly reach out and talk about this more. I know this was a really high-level overview today, so if you would like more information and kind of we talk about how this might make sense for your business, happy to do that, and you can just let us know via the poll I just launched. All right, that is the last question that I see come in. We are wrapping up a few minutes early today. If you have any other questions, feel free to post them. I'll hang around for a few more minutes in case any others come in. But thank you very much. Appreciate having you on the webinar today. And we will be sending out the slides afterwards. So keep an eye out for that. And good luck with forecasting. Wishing you guys lots of success.